welcome to the lecture series. In this lecture series, we are going to discuss about the supervised and unsupervised learning. In that, we are going to come a glance of linear regression for the robotic applications. So in the previous lecture, we discussed about the robotic applications in a health monitoring section. In this, we are going to have a linear regression technique for the particular applications. So what is this linear regression is? It is used for predictive modeling and it focuses on control systems, and it is used for adaptive learning and feature extraction. So linear regression is nothing but a statistical method for modeling a relationship between the dependent and independent variables. So we can use it in the prediction concept and minimizing the residuals in the equation to find out the equation of a line and in a linear relationships, and for the line of regressions also. So you can you have a glance in this diagrammatic representation. And what is this predictive modeling is? It enables the robot to predict outcomes based on the sensor's data, and in the control system it is used to optimize the robot's movement and positions. And in coming to the adaptive learning, it allows the robots to improve performance through the experience. And what is this feature extraction is nothing but it helps to identify key patterns from the complex data sensors data sets. And now understanding the list linear is uh, robot needs through observation and engagement. So a robot has to learn from the observation and the engagement. So first one is observe robot behavior, identify the patterns in the robot performance and limitations, and we have to engage the user. So the operators try to understand pain points and desired improvements. And coming with the systems, their systems have to understand how robot process data and make these decisions. And next is to identify the opportunities. So we have to discover the linear regression can enhance robot capabilities or not. And coming to the applications of linear regressions, we can use it in finance, healthcare, marketing, real estate, and supply chain. And coming to the defined stage, here the main problem is how can a linear regression enhance a robot precision and adaptability. So first is to identify specific robot functions requiring the prediction capabilities. So we have to find out the specific robot function, and we have to prioritize the needs. So we have to determine which challenge in the linear regression can address most effectively. And to formulate the hypothesis is nothing but to establish clear objective for the regression model performance. And we have to frame this problem, and which regression requirements is within this context. We have to frame it. So we have to define the scope. In that scope we have to prioritize, and we have to formulate a hypothesis, and we have to frame that problem statement. So coming to the data preparation part in the linear regression, first of all we have to fill the missing data, that is unenabled data, and we have to standardize this data, and from that standardization we have to normalize it, and from this normalization we have to look for the collinearity, and afterwards we have to remove that outer layers. So these are the data preparation part focused in this linear regression technique. And in the fundamentals we have to go with the very basic equation, that is y is equal to beta naught plus beta 1 x plus epsilon. So in the it is a fundamental mathematical foundation uh, which shows the relationship between the independent variable and the dependent variable. And least square method, sometimes it's used to minimize the sum of square residuals to find out the optimal parameters. So beta 1 is nothing but the coefficient, and beta naught is nothing but the intercept, and epsilon is nothing but the residual, that is the difference between the observed and the predicted value. And r square value is nothing but the proportion of the variance in the x explained by the variance in the y explained by the x. So here you can see a simple linear regression. We have the exam scores, here the hour of studies, and the intercept line. So we have a lot of works inside this exam work. So we are forming an intercept line. So for that we have to look for these how many activities we have to do before that getting into the exam. And developing is we have defined the statement. So from that we are going to create a solution, that is generate diverse ideas within the constraints, and collaboration ideations leverage multiple perspectives for the innovation. So here we have to focus on the four features like sensor calibration, path optimization, energy management, and human robot management. And here we also focus on the motion control and sensor calibrations. Coming to the prototype development, we look for the simulation environment, embedded implementation, performance optimization, and real-time adaptation. And coming to the last part, we go for the testing like cross-validation testing, real-time testing, A cross B testing, and error analysis. So overall, we'll focus on the four important features like mathematical foundation, implementation, applications, and performance metrics. In the next lecture series, we will discuss about the another interesting topic. Thank you.